Welcome. Today I want to talk to you about beyondOne. I describe it as a new way of working, Nats and Go working beautifully together. So let's dive into it. I was inspired by BusyBox. BusyBox 127 actually has more than 300 programs, but one deliverable, one executable. What if you could have request reply like a REST, HTTP JSON type service, event processing, persistence, delivered as one executable binary. And that executable binary, because it is built in Go, can be built, it's pure Go, it can be built to target all Go targets. Here's the good news, you can with the beyondOne method. Let me show you how. Basically, the process is 3 steps. First, you need to embed Nats. It's a Nat server, it's embedded in your code. Write your code in the form of Go routines and then build for your target platform. How would you embed a Nats server? Let's work on a request reply example. So you can see here, we embed Nats, we start some sort of mathematics service, and we have some sort of requester here. To embed Nats, just say new server, provide it with some options, start the server and connect to it. Here are the connection details. For convenience, I've declared some global variables, Nats connection and error. We wait for the server to be ready. We connect it to Nats. In this case, it's running on localhost port 4222. And wait for Nats server ready is essentially a built-in function ready for connections. It's a for loop, it runs until it's ready. It blocks until it's ready. So let's go ahead and build and start our embedded server. So let's do that. I call my binary temp my server. I'll run it, okay. Request reply demonstration. Server started. Ignore this for the time being. So let's ping the server using a Nats command line utility. You can actually download the utility from this location. So I'll publish something. The way you read this command is this is the Nats command line utility. Publish to the subject or topic hello, the contents world. And it works. Publish 5 bytes to the topic or the subject hello. Now you publish 6 bytes. Good. How do you know that I don't have another server running? Let me shut this down and publish again. No servers available. Start it up again. Now it's properly published again. Good. So let's write a mathematics summing service. And instead of using REST or HTTP JSON, let's use Nats and just plain old text encoding. So this is how you describe, or this is how you define a service in Nats. It's essentially a subscription to a topic or subject, and your code is here. This is the code, reply with some. You pass the message. If it doesn't pass, respond with an error. If it does pass, respond with a sum, right? Let's look at it in action. Well, we can do that. My code is actually already running, so I don't have to run it again. I'll clear this. So Again, I'm using the nets command line, issuing a request to this subject or topic, and these are the numbers I want to add up, and it says 2 and 3, 5. It's got error handling. I did not understand 3A. And if I give it some weird format, it says I don't understand the format. So it's a decent service. So how is the mathematics sum service requester written in code if I do not want to use the nets command line? It's a Go routine. That Go function, that's a Go routine. It's a forever loop. So we ask the user to enter some input. We scan it in. We wait for a second for timeout, right? And we send the request exactly like how we send the request here. We send the request programmatically, and we will receive the output as M, and we print it out. So let's look at that in action. I've already started the server right here. So let's enter 4 and 5 just for the fun of it. There you are. Sum of 4 and 5 is 9. It's exactly the same. Let's enter pi. I don't understand. Okay, 3 and 4a. Invalid syntax. Exactly the same. All right, let's stop there. So there's a lot more this beyondOne methodology can offer. Would you like a database, a key value store for free? How would you get a key value store for free, you ask? Well, let's go and start up our code again. Let's start up our code. I should have stopped it, but let's start up our code again. Right? With the code started up, I will use the nets command line utility again. It is based on nets jetstream capabilities. By embedding the nets jetstream server, you get a key value store for free. Nice. Let's exercise it. Add a key value store bucket. Key value store created. Okay. Let's put Apple. And let's get A. So put, we get this Apple. We change it to boy, just for the fun of it. We can get A, it's boy. Now, persistence, all right? I terminate the program. Of course, I now can't get anything. Oops, sorry. Start the program up again. If I now try to get my KV A, would I get an undefined thing? Does it actually persist, or will I get boy, which was what I created previously? Let's look. Yes, it persists. It's a proper key value store, and all it does is write to some file somewhere in block storage. That's it. Embedded database. Right. Some programs run fast, others run slowly. In broadcasting, this is common. We deal with movies that are gigabytes long. So, temporal decoupling, that's what event streaming offers you. So let's say you have a shopping list, a to-do list for a wedding, like hire a photographer, book a restaurant, and so on and so forth. Defining the list takes quite a short amount of time. but actually doing the items on that wedding planning list takes much, much longer. Say you ask a computer program to execute these wedding preparations. What will happen if the program was interrupted? Would it start again from the beginning? If you don't want it to start again from the beginning, what would it take for it to remember its place? Do you think it's a complex program to make this reliable? Let me show you how easy it can be with the beyondOne method. So here's the wedding preparation list. I've numbered it sequentially. There are 11 items. I just randomly threw them together so that we can see what has been done and what's not done yet. So this is how we initialize the event stream. Embed nets as usual, you've seen it before. Define event stream and process event stream are new. So define event stream is if we don't want to initialize the stream, return. If not, add the stream and feed the events from the list we just saw. So how do we know whether we want to initialize the stream or not? We look at the arguments, right? If the arguments contain the word start and only start, we will initialize. Otherwise, we skip it. And this is how you add a stream using jetStream. The stream name is wedding, and it looks at two subjects or topics. The wedding itself topic, or wedding dot greater than means anything under wedding dot. It could be wedding list, it could be wedding list rehearsal, wedding list, actual day, that sort of thing. It doesn't matter. As long as it's got a wedding dot and anything under it, it will be streamed under this wedding stream. And this is how we feed the events. Just go through the list and publish it to the wedding list. In this case, it's a wedding list. Right, so actually what I'll do, instead of this command, I'll actually create a okay, so I'll I'll build temp event stream. It's built, right? And let's see if we have any stream defined. Actually, what I'll do is I'll remove the streams first, just for good measure. Just for good measure, I'll remove the streams. All right. Oh, it's already no streams defined. Okay, so there are no streams defined. And let's go and start a stream. Let's go and start a stream. So it's actually already processing the wedding proposal, right? I purposely inserted a delay. Let's stop it, right? For now, let's stop it. We remember it stopped at 2, so the next item should be 3. Let's look at the stream list first. Oh, I stopped it. Okay. Let's look at the stream list. Don't worry about that. Let's look at the stream list. 11 messages in the stream list. Just ignore this for the time being. And let's look at what's in the stream list 3 at a time. So number 1, proposal accepted. So for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So there are 11 items, and it's going through the 11 items. Okay. Sorry for bouncing back and forth. It's exhausted all 11. Let's stop that for the time being. So how do we execute our wedding preparations? Process event stream. So if the wedding stream is not present, to avoid an error condition, just skip the processing. If not, it's again a go routine. It's a forever loop, should never exit, right? And the key to the whole thing is fetch. So fetch will give you a message, and it will say the wedding planner has executed this particular event or message. Messages have to be acknowledged. This is the retry mechanism in Jetstream. And I artificially, even machine wedding planners take time. 5 seconds, all right? Not too long. So this is how you check for the presence of a event stream. There's a built-in function called stream info. And you just look for the stream name, right? If it is present, the arrow will be nil, and it is present. And this is how fetch works. So you subscribe to wedding list, and this over here is what Nats calls the durable name. It's the client ID. So in this case, the client ID is wedding planner. And we can fetch, for performance reasons, we can fetch a batch of messages. In this case, I only decided to fetch 1, but for high performance, you can fetch 10, 100 or 1,000 messages in one go. It checks for timeout because it's a continuous forever loop, and if there are no messages, it will time out. I don't want it to error, so I say return without error. And if the length of the messages is not 1, because I'm only asking to fetch 1, if it is not 1, say an unexpected number of messages return, and then return the actual message. So let's go and see it in action. As I said, it's already run. I'll clear this for easier. Now I think the stream has exhausted. Yeah, it's exhausted. It's good. Let me start it again. The keyword start actually injects another 11 items into the process list. So just think of it as another wedding to plan. So 1, all right, has run. 2 has run. The next would be 3. Would it be 3? Of course it would be. Of course, all right. And then you'll go on until 11, and you'll stop, and then you'll wait for another wedding to come by, another 11 items to come by. So that is how the beyondOne process can temporarily decouple the event feed and the event execution. The code and presentation can be downloaded from my GitHub repository here, and thank you.